Welcome to the training series on the Ohio Department of Transportation's Benefit Cost Analysis, or BCA tool, for active transportation improvements. This is Module 1 of our four-part series. In this module, we'll introduce benefit cost analysis and help you understand when to use the active transportation BCA tool. The second module will walk through a specific project example. Module 3 demonstrates how to develop sketch-level project costs using the Cost Opinion tool, and Module 4 covers guidance on walking and biking trip estimation. In this first of 4 videos, we'll introduce benefit cost analysis, what it is and when to use it. We'll examine the types of benefits captured in the tool. We will show you how to navigate this tool and discuss the data you need before you begin. Finally, we'll touch on modeling multiple projects. Benefit cost analysis, or BCA, is a way to compare the expected benefits and costs of a project over time. This helps determine whether a project is worth the investment. This BCA tool is tailored specifically to active transportation projects like walking and biking improvements. The tool applies dollar values across diverse types of benefits associated with these projects. This way, we can compare benefits and costs in dollar terms, an apples-to-apples comparison. The tool can also be used to help make the case for federal or state funding. BCA is designed to evaluate the overall social efficiency of an improvement. The dollar amounts assigned reflect people's willingness to pay for improved outcomes. BCA is different from other analyses you might see, which look at how projects affect finances, generate tax impacts, or influence growth in the economy. Before we go further, a bit of key vocabulary and concepts related to BCA. When we refer to costs, we are referring to both capital costs, such as design and construction costs, and ongoing operating and maintenance costs. Because transportation projects have impacts for years, we must consider both the effects of inflation and the time value of money. Year of expenditure dollars reflect how inflation changes buying power. They represent the actual amount of money needed to purchase something in that year. We can also express costs as constant dollars, which allows common comparison across years. Constant dollars involve an adjustment so that expenditures in, say, 2023 and 2030 can be considered on equal footing. This BCA tool is conducted in constant 2023 dollars. Another concept related to multi-year benefit cost calculations is discounting. Discounting allows us to give greater weight to benefits and costs that occur closer to the present. In other words, to what extent do we discount future benefits and costs? This tool applies a standard US DOT discount rate year over year to help us calculate a project's costs and benefits in their present value. From here, we calculate the net present value, which is the total present value of benefits minus the total present value of costs. We can also express these numbers as a ratio, the benefit cost ratio, or BCR, which is total present value of benefits divided by total present value of costs. A BCR greater than 1 suggests that benefits outweigh the costs. We can then model different projects and compare their BCRs to see which have the biggest bang for their buck. This tool compares a no-build scenario, what happens if we do nothing, with a build scenario, what happens if we invest in improvements. Active transportation projects, like pedestrian and biking paths and marked crosswalks, have a range of benefits. This BCA tool includes 7 general types shown on the slide. All calculations align with US DOT guidance. Let's walk through each benefit. Safety. Certain infrastructure improvements have a demonstrated effect in reducing crashes and injuries. This tool uses a crash modification factor, CMF, to estimate this reduction, and then we value this benefit in dollar terms, as with all of the following benefits. Travel time savings. New improvements can lead to people switching from driving to walking or biking. We call this mode shift, and it results in changes in trip times. We measure travel time for trips based on speeds and modes. Vehicle operating cost savings. Mode shift away from driving also results in fewer driving miles, which in turn means less money spent on fuel and vehicle maintenance. Emission reductions. Less driving additionally means fewer harmful pollutants in the air, referred to as emissions. Avoided highway externalities. Avoided externalities capture the reduction in congestion, noise, and risk due to fewer cars on the road. We refer to these effects as externalities in that the benefits and costs are borne not by the individual user, but by society as a whole. Amenity. We must also consider that walking and biking can be a nicer experience for people. Better walking and biking environments, like wider sidewalks or marked crosswalks, make travel more enjoyable and accessible. We value this based on people's observed preferences for higher quality infrastructure. And finally, health. More active travel and less sitting in a car means better cardiovascular health and ultimately lives saved. Now that we understand the general and specific concepts related to this BCA tool, let's examine its structure. The full spreadsheet-based tool has 19 tabs, but don't worry, most of these are used for back-end calculations. As a user, you'll typically use only 6. First, you have 3 green tabs for required data entry: project information, inputs, and the safety amenity toggle. For projects with safety components, there's an additional red tab for optional safety inputs. You use this tab if you have crash data and want to apply a CMF. Finally, we have the yellow results tabs. You can view the summary table of benefits by type, or if you want a final benefit cost ratio and net present value, you can consult the final results tab. Next, we'll show you what this all looks like within the actual BCA tool. We'll start with those green input tabs and talk about what input data you'll need ready. First, you will need some basic project information: when construction starts and ends, and the operational period is typically the expected useful life of the infrastructure. From here, we have the Inputs tab, which is the most involved and central tab for data entry. This is where you'll enter values for both the build and no-build scenarios. Depending on your project, not all fields will apply. First, we have the project info, construction and operations and maintenance costs, and the estimated annual growth rate in trips. Second, we have roadway characteristics, traffic speed, and average annual daily traffic. Third, we have the specs and projected use for walking or the pedestrian environment, the average number of daily walking trips, the length, width, and slope of the sidewalk, and the number of users in crossings that are newly marked or signalized. Finally, we have inputs for cycling improvements: the average number of daily cycling trips, the length of the roadways with any of the following: sharrows, dedicated bike lanes, cycle tracks, cycle paths with at-grade crossings, or cycle paths without at-grade crossings. If the project you're modeling only involves walking improvements or cycling improvements, you can leave the irrelevant box's values at 0. So, while this tab is the Required Data Input tab, not all inputs will be relevant. Next, we have our optional red tab for safety benefits. If the proposed improvement is expected to have safety benefits and you have a demonstrated history of crashes using data from the last 5 years, you can use this tab. First, select an improvement type that best suits your project from the dropdown. This enables the model to select the appropriate crash modification factor, CMF, from the FHWA CMF clearinghouse to estimate the share of crashes that will remain after the improvement. Then you enter the no-build crash data based on historic counts by CABCO severity category. If these values stay at 0, there is no calculated benefit. Once you've done all of the above, be sure to consult the Safety Amenity toggle. This toggle allows you to choose whether to include amenity benefits or safety benefits, depending on which is calculated to be greater. The tool will indicate which benefit makes the greatest case for the project. Why one or the other? In short, including both safety and amenity benefits would result in double counting overlapping benefit types. We don't want to inflate benefits, so we instead err on the conservative side and select only one, whichever is greater. This tool is built for one project at a time, but if you need to simultaneously assess multiple projects or multiple components that have unique costs and trip, crash, or improvement data, users can copy and paste results from the Summary by Benefits tab into a separate workbook to add them together. This wraps up Module 1, our overview of benefit cost analysis and how this tool works. In Module 2, we'll walk you through an example, showing you how to enter data and interpret the results. Thanks for watching. When you're ready, continue to Module 2 BCA Walkthrough with Examples. Feel free to also consult the BCA User Guide PDF available on the website shown here.